So we're expecting a negative value for u. If we rearrange the lens law equation, we have 1 over v equals 1 over f minus 1 over u. Let's substitute the values in now. The focal length is 8.0. The object distance is 6.5. So 6.5 here. And when we calculate that, we find that v is minus 34.7 centimetres. When we calculate this, we get a negative value. And this is exactly what we're expecting, as we know that we get a virtual image. Therefore, the distance from the optical centre to that virtual image is expected to be negative. So minus 34.7 centimetres. And finally, calculate the linear magnification of the magnifying glass when used in this way. Our equation is m equals v over u. And we can ignore the negative here, as the negative represents the fact that it's virtual. So the image distance is 34.7 divided by the object distance of 6.5 gives us a magnification of 5.33. There's 1 mark for the substitution. Even if you have an incorrect value here in part 1 and use it correctly in part 2, you can get the mark for the substitution and a mark for the calculation of the final answer. And the linear magnification is 5.33. This means that the image will be 5.33 times the size of the object. So let's look over that question again. Initially we had to identify what lens is used for a magnifying glass, given the information. We then had to draw a ray diagram for the magnifying glass being used in that aspect. And using some measurements of the focal length and the object distance, we had to find the image distance, which we found to be a negative value, which is consistent with a virtual image. And we then used the answer to that along with the object distance to find the magnification for that lens.